हेलो एवरीबॉडी, आप सबका स्वागत है फ्लूइड मैकेनिक्स के लेक्चर नंबर 1 में। आई होप गाइज दैट यू गाइज आर डूइंग वेरी वेल, योर प्रिपरेशन इज ऑल्सो डूइंग वेरी वेल, राइट? एंड गाइज, the students who are not enrolled yet and you are thinking about the preparation of the GATE examination, this is the right time for the preparation, guys. Do not wait for single 1 minute, right? Because as you know that we don't have that much time that we will think over it and we will decide that should I prepare with coaching or not. This is the right time, guys. Okay, so as you can see on the screen, it's my lecture number 1 of the fluid mechanics, and for most of the students fluid mechanics is a very difficult subject, right? It may be, but if your approach is right, if your guide is right, if your mentor, if your faculty is right, I think fluid mechanics is a very beautiful subject, guys. It is the, you can say, concept, it is the basically physics plus mathematics is the, you can say, combination, right? So don't fear, बिल्कुल डरने की आवश्यकता ही नहीं है. There is no requirement of your, you can say, fear. फ्लूइड मैकेनिक्स आज से आपका फेवरेट सब्जेक्ट होने वाला है. डोंट वरी अबाउट दैट. वी विल स्टार्ट विद द जीरो एंड हम इस सब्जेक्ट को नेक्स्ट लेवल तक लेके जाएंगे. वी विल टेक दिस सब्जेक्ट टू द नेक्स्ट लेवल, गाइज, राइट? यू विल फील so much confident into this subject that you'll say after the completion of this subject, okay, फ्लूइड मैकेनिक्स का तो एक सवाल भी मैं गेट एग्जामिनेशन में ड्रॉप नहीं करने वाला हूं. आई कैन अटेम्प्ट ऑल द क्वेश्चंस ऑफ फ्लूइड मैकेनिक्स, राइट? So strategy to crack this subject is that, first of all, we have to start this subject with very, very basic things, right? If our fundamental is strong, we can, you can say, build our buildings. आप कितने भी माला खड़े कर दे, फिर आप चाहे आप 10 मंजिल फिर फाउंडेशन पे आप खड़े कर दे, there is no problem at all. So I'll start this subject with very basic, right? मैं consider करूंगा, I'll consider that you don't know even single thing, right? And our approach should be, you can say, that conceptual approach. I'll discuss this subject with some good, you can say, animation, so that you can think over it. You are able to think all the things. Okay, we will solve some good questions, some good quality questions of our references book. Also, we will discuss the PYQs, very, very important. Okay, so you will feel, you can say that, very comfortable in this fluid mechanics. This is my, you can say, the promise to you guys. Okay, let's start this subject. So I'll start this subject with the name fluid mechanics. So guys, fluid mechanics is basically categorized in the two parts, fluid statics and the fluid dynamics. Okay, now the question arises here, what is the meaning of fluid static and what is the meaning of fluid dynamics? So this word static is basically what? This word static means that something is in the static position, means something is in the rest position. It is clear to you? So fluid static means that your fluid is at rest, guys. So it may be possible that the container and the fluid, both the things are in the rest position, or it may be possible that your fluid is at rest with respect to the container. If your fluid is at rest with respect to the container, this is also called fluid static, because our reference is our container. We have to study the fluid, not we have to study the container. Yes or no? So we will study in some part the fluid with respect to the container, right? So I hope that fluid static definition is clear to you. What is the meaning of fluid dynamics, sir? Fluid dynamics means, like, let's suppose your fluid is flowing in a pipe. Like in this animation, you can see that fluid is basically not stationary at all here. Your pipe is stationary, and if you will see that there is a motion of the fluid with respect to the pipe, guys. What I'm saying, your fluid is in the motion with respect to your pipe. It is clear to you or not, right? So this is called fluid dynamics. Okay, this is called a fluid dynamics. Okay, I'll ask a question to you guys. Let's suppose your pipe is moving with the 5 meter per second speed, and your fluid is also moving with 5 meter per second on the basis of ground, means you are basically measuring the speed with respect to the ground, and with respect to the ground, pipe and the fluid both has the velocity 5 meter per second. So this is comes into the category of fluid static or fluid dynamics. Think over it. Think for the 5 seconds, guys. Think. So answer will be, guys, see, you have to see the fluid with respect to your container. If you will see the fluid velocity, or you can say the fluid speed with respect to your with respect to the pipe is 0, right? The pipe and the fluid both are moving in the same direction with the same speed. It means that there is no relative motion between them. It means that that fluid is basically at the rest position with respect to the container. So that also comes into the category of fluid static, right? So fluid dynamics means that if your you can say fluid is in the motion with respect to the container, that comes into the category of fluid dynamics. I hope आपको ये simple बातें समझ में आई होंगी, right? See, I'll use a English word, you can say English language in such a way that you can easily understand it. Means जिसको हिंदी में भी पढ़ने की you can say आदत है, वो भी easily मेरे words को आसानी से समझ सकता है. There is no problem at all, right? Also, I'm comfortable in both the language, means English and Hindi also. So if somebody is not comfortable with the English in any part, right, then you can ask, I'll explain in the Hindi also. There is no problem at all, right? Because our students are you can say सब हिंदी समझने वाले भी हैं, कुछ प्योरली इंग्लिश समझने वाले भी हैं, right? Okay, so guys, I hope that these things are clear to you, right? So I think there is no need to explain further what are the meaning of fluid static and the fluid dynamics. Now the question arises in our mind, or basically this question arises in the mind of other branches student. Why you guys study the fluid mechanics? Why this fluid mechanics is in your syllabus? So first of all, if you will say to somebody that I'm studying the chemical engineering, the first reply, the first response of that other guy is, okay, you are good at chemistry. I hope that you guys ये same चीज सबने feel की होगी. Okay, you guys are good at chemistry. Wow, very good. Right? But the reality is, chemistry तो हम पढ़ते ही नहीं हैं. Chemistry is the part of, you can say, science people, MSc, BSc, right? We are engineers. Okay, so अदर कोई किसी ने बोला, किसी दूसरी ब्रांच ने, why you guys are studying the fluid mechanics, right? So today I'll give you the answer of it, why we study the fluid mechanics. Chemical engineering is the branch, you can say it is the branch actually. I'll say it is the mother of all the branches, because chemical engineers know everything in the aspect of other branch also. You will say, sir, how? See, just we completed a subject IPC, instrumentation and process control. If you will say, guys, that subject is purely, you can say, of the instrumentation people. Instrumentation is also a branch, you know that, right? But we have the knowledge of that also, instrumentation, process and control also. We have the knowledge about the IPC. Fluid mechanics is the core subject of the mechanical and the civil engineering. But we know also, we do have the knowledge about the fluid mechanics also. It is clear to you or not? So we'll have the knowledge about the other discipline also, right? That's why if you will see in the industry, when hopefully you will go into the PSU and you will handle the plant, then chemical engineers are the main, you can say, main component of industry, specifically in the PSUs like IOCL and all that. All the other department will assist you. right? And you are able to coordinate with them. Why? Because you do have the knowledge of everything. If any mechanical guy come to you and that if you he'll discuss to you about the pumps and all that, okay, this is the pumps and this is the problem in the pump and all that, about the plant, you will understand everything because you do have that knowledge. Now coming to the part why fluid mechanics is important for the chemical engineering. Guys, एक्चुअली केमिकल इंजीनियर्स जो हैं वो फ्लूइड में ही रहते हैं, है ना, उनका काम ही फ्लूइड में रहना है. ओके, सी इफ विल टॉक अबाउट लाइक फ्लूइड्स जो हैं हमारे, जैसे कि कोई भी क्रूड ऑयल है, वाटर, स्टीम, गैस, एनी केमिकल्स, दैट इज बेसिकली किसी भी पाइपलाइन में से ट्रांसपोर्ट होते हैं, है ना. फ्लूइड इज बेसिकली ट्रांसपोर्टिंग टू वन लोकेशन टू द अनदर लोकेशन. Is it clear to you or not? So we have to be very specific at the end that how much flow rate should I maintain at one end. Is it clear to you or not? So we should have the knowledge about the flow rate, velocity, what can be the pressure drop, what can be the pipe diameter and all that. If we'll talk about the pumps, compressor selection, that also you can say pumps basically are using to transport the liquids and compressor is using to transport the gas. It is clear to you or not, right? So that also it is related to fluid also. It is also related to the fluid, guys, isn't it? Third, reactor design. In the CRE, you are basically, reactor design is our main concern. We are the chemical engineers and CRE is the subject which is the purely the core subject of the chemical engineers. और कोई ब्रांच नहीं पढ़ती है CRE को, right? And in the CRE our main purpose is to design the reactor. ओके, जैसे कि सर आप लोगों को ब्यूटीफुल तरीके से समझा रहे हैं जो CRE है. सो नाउ यू डू हैव दैट आइडिया दैट वी आर मेन कंसर्न इज टू डिजाइन द रिएक्टर इन द CRE सब्जेक्ट. यस और नो? सो कैसे? अब दैट रिएक्टर इज बेसिकली डीलिंग विद द फ्लूइड्स ना, इट इज डीलिंग विद द फ्लूइड्स, गाइस. यस और नो? राइट. सो we have to determine its mixing quality, its residence time, flow pattern, pressure loss. How we can calculate that if we'll have the good knowledge of that fluid. Also heat transfer operations in the heat exchangers, we have to deal with the fluids, how the fluid is basically going through the pipes of the heat exchangers, how it flows, how the pressure is dropped. It is clear to you or not? How it will corrode the tubes and all that, how which fluid is can corrode the you can say the tubes, which can withstand on the tubes, right? If you have the good knowledge about the fluid, then you can select the fluid, that which fluid is going towards the shell side or the tube side. So there are multiple examples, guys. Mass transfer operations, right? That we use distillation, absorption, extraction, drying, humidification, right? It is clear to you? So lots of the examples that in every operation, the fluid behavior of the fluid is very, very important for us. It is clear, right? So fluid mechanics helps us to design the safe, efficient and economical chemical plants, right? So this is why the fluid mechanics is important for us, because we have to deal with the fluid transport, we have to deal with the pump, compressor selection, reactor design, heat transfer operations, heat exchangers, pipeline designing. In the chemical engineering discipline, in the job profile, there is a process engineer is a profile. One is a production engineer, one is a process engineer. That they basically design the pipelines and all that. They design the whole plant. It is clear to you or not? They can save the energy. Okay, so this is why the fluid mechanics is important for us, important for the chemical engineers, guys, right? Okay, great. So now let's start the fluid mechanics, and I hope that this definition is clear to you. Basically, fluid is a term, and I'll explain this term further. But okay, fluid is basically, guys, fluid means what? It may be possible that you guys are think about the fluid means liquid. No, fluid means both liquid and liquid is also termed as fluid, and the gas is also termed as fluid, guys, right? So liquid is also a fluid, gas is also a fluid, right? Okay, Now, before starting our main, you can say, content, we should have knowledge about some small terminologies which are very important for us, right? So let's understand the meaning of stress and strain. Okay, so what is the stress? It may be possible that some of you will say about, sir, that stress means दो हमने गेट एग्जामिनेशन के बारे में सोचकर जो हमने दिमाग में स्ट्रेस ले रखा है, that is stress. Yes, that may be a stress, right? If you will not study, you can say, efficiently, then that will be stress. I know that. But if you will study efficiently, you will do hard work when you will solve questions. Questions solve होते जाएंगे लाइन में. You can solve every question if your fundamental is strong. Then I think that will not be your stress. वो आपका एक dopamine होने वाला है आगे चल के. Right? Okay. Let's come to the stress part. What is the meaning of stress, guys? What is the meaning of stress? Okay, so stress means it is simply force upon area. It is force upon area. This is the, you can say, the broad, you can say, the formula, force upon area. It is clear to you? So actually force may be anything, because force is we know it is a vector quantity, right? There are two kind of stresses there. Okay, one is your normal stress. One is your normal stress. Normal stress means the daily life stress which will carry on your head. No, it's not that stress. Normal stress. And another is your shear stress. Shear stress. Normal stress is denoted by the sigma and shear stress is denoted by the tau. It is denoted by the tau. So let's try to understand it, guys. Normal stress and the shear stress. Normal, I hope that you guys are aware about the meaning of normal. Normal means anything which is perpendicular to the surface. Let's suppose this is a surface. As you can see, this is the surface, guys. This hole is a surface and I have a dA area. At this point, dF force is applying in this direction. dF force is applying in this direction. Let's suppose this force is making an angle theta. Making an angle theta with the horizontal. It is clear to you? So this dF force has two components. Because force is a vector quantity, we can resolve the component of a vector quantity. I hope to get that. I hope that you guys are aware about it. But if you are not aware about it, tell me. I'll explain it also. So force is a vector quantity, guys, and it is applying on a dA area, right? So it is making an angle with the theta with the horizontal. So this dF has a two component. So resolve this force, guys. So one is this and one is this. Okay, this is my tangential force and this is my normal force. This is my tangential force. So dFT is my tangential force. What is it? Nothing. It is my dF cos theta. You know that, right? This is the cos theta, and this component is my, it is known as normal force, and it is my dF sin theta. It is clear to you? So this is the dF force. A part of this force is applying on the this side, which is, you can say, tangent on the, in the direction of the tangent on this surface, and some part, the remaining part, or you can say the some part of this force is applying on the normal to this surface. And these are the different component of it. This is the partition of it. It is clear? So normal stress means, what is the definition for the stress? Force upon area. In the normal stress, you have to consider the normal force, that is dFn. dFn divided by what is the amount of area? dA. So guys, what is your dFn? dFn is nothing. It is my dF sin theta divided by dA. So this is the amount of the normal stress. It is the amount of the normal stress. It is clear? Shear stress. Shear means, the shear stress is basically, you can say, it is basically coming due to the force which is applied tangentially to the surface. Tangentially to the surface. It is clear? Let's suppose I'm saying that this is my surface. Okay, this is my surface. One, I hope that guys are visible to you. This is my force, right? So one force is this and one force is this. One force is this, means it is a tangential to the surface, and one force is this is the normal to the surface. So shear stress is coming due to the tangential force, due to the tangential force. It is clear. So one force which is applying on the tangential direction, that is responsible for the shear stress. It is clear. So that force per unit area will be your shear stress. So that will be your dF T divided by dA, and your dFT is nothing, it is my dF cos theta divided by dA. It is clear, right? What can be the unit of the stress? Very simple. Force means Newton, area means meter square. So Newton per meter square is the unit of the stress, and there are two kind of stresses, normal stress and the shear stress. It is clear to you, right? So here also I write all these things. Done. So this is the stress. Now let's see, due to the stress there may be a strain in the body. Due to the stress there may be strain in the body. You'll say, sir, how? What are you trying to explain? देखो भाई, समझना इस चीज को, ठीक है, समझना इस चीज को. This is AC remote. For sure I'll not break this remote for you. ठीक है, but I just try to explain this. Just try to understand it, okay, in a very simple language. This is a body. This is a body, and I am applying some force on it. मैं कुछ force apply कर रहा हूँ इसके ऊपर, right? That force may be normal to the surface or tangential to the surface. Okay. Okay. Let's suppose that I'm applying some force tangentially to this surface. मैंने कुछ इस surface पे कुछ force लगाया. Let's suppose its length is some L. But मैंने कुछ force लगाने की वजह से, by applying the some amount of force, this body can deform. This body can elongate. Or if I'll compress it, then it can compressed. Means the size of the body can be you can say less as compared to the original in the compressed situation, right? If I'll you can say spread it, then the length of this body can be more as compared to the original. It is clear to you or not? So strain is that measurement actually. So what is the strain? Strain is your change in dimension. Change in dimension divided by original dimension. Divided by original dimension. So further strain is also defined in the, you can say, different form. Like in the dimension, it can be linear, it can be areal, or it can be volumetric. Depending upon that, strain is also defined in the different terms. Okay, but that is not required for us. That is not required for us. Okay, so I'm just taking the very simple that let's suppose that change in the dimension is linear, means the length is change. So that is strain is actually change in the length divided by the original length. Divided by the original length. It is clear to you or not, right? So this is my strain, and as I said that it is in the linear form, then actually the right term for this is longitudinal strain. Longitudinal strain. I hope that this is clear to you. Okay, so these are the two terms, stress and strain. So I'll use you can say very frequently this term, shear stress. I'll use this term very frequently, that is called shear stress. Okay, so I hope guys that you are okay with it, right? Done? Okay, let's move further guys. Let's move further. Now the question is here, what is the meaning of fluid? We are basically studying the fluid mechanics, but first of all we should have the knowledge about what is the meaning of fluid. Which component should I call them as a fluid? It is clear to you or not? Okay, so the definition for the fluid is a substance which is capable of flowing or moving or deforming under the shear force. Under the shear force. It is clear to you or not? Right? What I'm saying, guys, what I'm saying. See, fluid, let's suppose some component is there, some component is there, and this is not flowing. So if it is not flowing, then you cannot say it is not fluid. Then what is the definition? Definition is that if you apply some shear force, if you applying some shear force, due to that shear force, if some body is deformed, if some body is, there is some movement in that body, or it is in the stage of flowing, then that substance is called the fluid. That substance is called the fluid. Shear force is what? Are nothing. That tangential part wala force is called the shear force. Okay, right? So this is basically called the shear force. Don't worry about that, right? Which is responsible for the shear stress. That force is called shear force. Okay, so you can see this. This is, let's suppose, my fluid element. This is my any fluid element, right? And I'm applying to this surface, I'm applying some force. And let's suppose the original position of this fluid element is this. This is the original positions, right? This is the original positions, right? But while if I apply the force on it, then due to the shear force, this fluid element, this element is basically deformed. Now this position, the position of this point is this, and the position of this point is this. It is clear? Yes or no? So it is deformed actually. It is deformed while applying the shear force. That is called my fluid. That is called my fluid, right? It is clear to you. And in the fluid category, example, fluid is for here liquid and gas. Both are called fluid. Both are called fluid. It is clear to you or not, right? Okay. Now, what is this note? You can see what is this note. One fluid is called viscoelastic fluid. What is the meaning of viscoelastic fluid? See, you are applying a shear force here. Due to this shear force, there is a deformation in the body. When you remove this force, now guys, this fluid element will regain its original shape. That is called viscoelastic fluid. It is clear to you or not? It is clear to you or not, right? So I discussed what is the fluid. That okay, by applying shear force, it can deform and all that. What about the solid? What about the solid, guys? What about the solid? So if you will apply the shear force to the solid, what is the effect on the solid? So let's take any, you can say, solid body. Okay, this is the right example I have. See, this is a solid body. Yes, I am applying a shear force on this body. Okay, just observe the you can say situation here. What is going on? So I am applying a shear force here. But guys, see, believe me, झूठ नहीं बोलूंगा मैं. I'm applying a shear force on it, but I also feel some force opposite to my force. Okay, means I'm applying a shear force on this body in this direction, but simultaneously I'm feeling the force in the opposite direction, in this direction. What is the meaning? Meaning is that I am applying shear stress, but this solid is basically resisting me. It is basically resisting me. It is also applied shear stress on me. It is also applied shear stress on me. It is clear to you or not, right? If it is if it will be the fluid, then it will start to deform. अगर ये fluid होता तो ये इस shear stress के influence में आके deform होना शुरू हो जाता. But how the solid is different? Solid is applying the resistance force on me. It is clear? So this is basically the difference. So this is the force applied by me, and I'm feeling the force. This, it is applied by solid body. right? So what I can say that solid can persist or resist, sorry, solid can resist or applied shear force, whereas fluid deforms continuously under the influence of shear force, or you can say the shear stress, right? So fluid is starting to deform even with a very small shear force under, you can say, very normal. It will not resist at all, it will not apply the opposing force towards you. अगर आप उसको डिफॉर्म करने की कोशिश करेंगे, अगर आप फ्लूइड बॉडी को shear force लगाएंगे तो फ्लूइड आपको वापस से रेजिस्टेंस नहीं क्रिएट करेगा. So single, you can say that a very small amount of the shear force is also responsible for the deformation in the fluid. थोड़ा भी फोर्स जो होगा ना वो भी फ्लूइड बॉडी को डिफॉर्म कर देगा. But this is not for the case of solid. Solid will apply, you can say, the resistance. It will apply also a force opposing to it. वो अपने आप को डिफॉर्म होने से बचाएगा. I hope that these things are very clear to you. I hope that it is clear to you. Yes or no? Okay, done. Now, so as I told you guys that what is the fluid mechanics? Fluid mechanics is the branch of science that deals with the behavior of the fluids. Fluid means the liquid and gases which is at rest and in motion and the forces acting on them. It is clear. So we have two kind of branches there, that is hydrostatic, that is called fluid static, right? Hydrostatic means fluid at rest. Fluid at rest, right? One is a hydrodynamic. Fluid in motion. Okay, and in the detail I already explained this. Okay, these are not important for the exam point of view, but this will basically enhance your skills. This will enhance your ability to read any question. It is clear to you, that will be very clear to you if you'll have very good at the fundamentals, good at the very small things. Right now, please put the heading characteristics of the fluid. Now please put the heading characteristics of the fluid. Please put the heading characteristics of the fluid. Okay, so what are the characteristics of the fluid, guys? The first characteristic is that, see, let's suppose I have this cup, and if I'll pour some water to it, that water will basically gain the shape of this cup. Is it clear to you or not? Is it clear to you or not? If I'll pour this water into the other vessel, then that water will gain the shape of that vessel. Yes or no? So it means that fluid doesn't have the definite shape. कोई खुद की shape नहीं होती है. Solid has their own shape, like this. This has some shape. इस solid body की कुछ shape है. But if we'll talk about the fluid, guys, now there is no, you can say, specifically their own identity in terms of the shape. So my first point will be, it has no, I should use different color. It has no definite shape of its own. It is clear to you or not? So क्या करता है फ्लूइड, फिर जिस वेसल में आप उसको पोर करोगे उसी की शेप को रिगेन कर लेगा, गेन कर लेगा. इट गेन द शेप ऑफ वेसल. It is clear? Yes or no? Second point that I already discussed, that even a very small amount of the shear force, that is basically responsible for the deformation, right? So write it, even a small amount of shear force can deform the fluid. It is clear, right? So please write it. Please write it. Okay. Now we are going to study the fluid, guys. For that purpose, it is very important to discuss the properties of that fluid. What is the properties of that fluid? What are the characteristics of that fluid? Okay, if we are aware about the characteristic of the fluid, then we can easily deal with that. So please put the heading basic properties of the fluid. Basic properties of the fluid. It is clear? So these are the some properties, guys. These are the some properties. We have to discuss these properties: density, specific volume, specific weight, specific gravity, viscosity, compressibility, modulus of elasticity, surface tension, right? So these are the properties which are basically independent of the motion of the fluid. These properties are independent on the motion of the fluid, guys. Motion of the fluid, right? If if water is at rest, its density is 1000 kg per meter cube, and when it is in motion, then also it is 1000 kg per meter cube. It is clear? So it is basically independent on the motion of the fluid, right? So we will try to discuss all these properties one by one, right? So that we will aware about the properties, and these properties are important for us. Okay, while we will discussing everything, then these properties are, you can say, relevant for us, will help us to understand the basic nature of the fluid. Okay, it is clear? Okay ji, done. So please put the heading first, density. Please put the heading density. It is also called mass density. It is also called mass density. In the, you can say, your mass transfer, you study the mole density also, right? Because that is depend upon the moles also, right? Density, very simple. I think there is no need to discuss so much about the density. Density, it is denoted by the rho. Simply, it is the ratio of mass and volume. It is simply the ratio of mass and volume. It is clear to you guys, right? So it is the mass of the fluid and divided by volume of the fluid. It is clear to you or not, right? So I can say that density is equal to mass divided by volume of the fluid. It is clear? So if we'll talk about its unit, guys, what is the unit? SI unit, you will say kg per meter cube. Mass should be in the kg. It is kg per meter cube. Or in the CGS unit, I can write gram per cc. Gram per cubic centimeter, right? It is clear? Okay. there are some densities value which we will use again and again and again, and these are the simple values you studied in the from the class, you can say 9th or 10th. Density of the water in terms of kg per meter cube is basically 1000 kg per meter cube, right? It is clear to you. If we'll talk about the gram per cc, then it is my 1 gram per cc. You should have remember these values, guys. Okay, now density is the function of temperature, guys. Okay, if you will change the temperature, density will change. So these values 1000 kg per meter cube is calculated at some particular point, and in the thermodynamics we have already discussed about it. So please tell me that these value is at which temperature and pressure. It is a temperature is what? It is, I hope, 4 degrees Celsius. Okay, and if we'll talk about the pressure, then it is my 1 atm, 4.4 degrees Celsius. And what will be the pressure? Pressure will be your 1 atm. So this is the temperature and pressure condition on which these values are calculated. Okay, if we'll talk about the density of the mercury, guys, because these are the two liquids which are you can say very favorite for the fluid mechanics. So always remember about the density of the mercury. It is 13.6 times of the water. 13.6 times of the water. So if in the kg per meter cube, then it will be my 13600 kg per meter cube, and in the gram per cc, it is simply just multiply with the 13.6 gram per cc. I hope that this is clear to you. Done? It is clear? Please tell me. And if we'll talk about the temperature and pressure condition, then the temperature is my 25 degrees Celsius and pressure is your 180. Temperature is 25, means room temperature, atmospheric pressure. Atmospheric pressure. It is clear? Is clear? Done? Please write all these things, because these are small things, but these are very important. These are very important. So density, simply units should be clear to you. You should have the knowledge about the units, because units are very important for us. Okay, units are very important for us, and these two values are frequently used by us. We will use these units very frequently. Okay, so I'll write yes or no, guys. I hope that it is clear to you. I hope that this is clear to you, right? It is clear. If we will talk about the, as I told you, that it is the basically relation with the temperature. So see, guys, if I'll talk about your liquid, if I'll talk about the liquid, so let's suppose we are heating the our water. Let's suppose we are heating our water. So water will basically, density will be less or more if you will heat the liquid. I think with increasing temperature, your density will be decreased in the case of the liquid. Okay, in the liquid it is, if while increasing the temperature, density will be decreased. Yes or no? And for gas, please tell me, group पे सब post करेंगे. Is it so that while increasing the temperature, density will be increased, or you'll say that the you can say relations is same for as liquid? ये आपको मुझे बताना है, ठीक है, ये आपको मुझे बताना है हमारे टेलीग्राम ग्रुप पे, जिसपे हम बातचीत करते हैं, हमारे ग्रुप में हम अपने डाउट्स लेते हैं, ठीक है, उस ग्रुप में आप सबको बताना है मुझे, राइट। सो ओके, सो लिक्विड का मैंने लिखा है, गैस का ये सही है, और वी शुड चेंज दिस, टेल मी। ओके, सो दिस वन प्रॉपर्टी इज क्लियर टू यू। नाउ सेकंड इज माय स्पेसिफिक वेट, second is my specific weight or it is weight density. Second is my specific weight or weight density. It is denoted by the gamma. It is denoted by the gamma. What is the definition of the specific weight? See guys, in the examination, in the problem statement, you will find specific weight for this substance is this. Is it clear to you or not? If you are not aware about the specific weight, then how you will calculate the parameter values, right? Specific weight is nothing. It is the specific weight is the weight per unit volume of the fluid, right? It is the weight per unit volume of the fluid. So gamma is equal to weight of the fluid divided by the volume of the fluid. It is clear? So it is the weight divided by the volume of the fluid, right? Okay. Then what is the meaning of weight? What is the weight, guys? Weight is my m into g divided by volume. So mass upon volume is my what? It is my density, yes or no? So it is my rho into g. So this is why I write it gamma is equal to my rho into g. Rho into g. Right? So gamma is my specific weight. In the SI unit, it is my Newton per meter cube. Because weight unit is my Newton and volume is my meter cube. What is W? W is the weight of the fluid, V is the volume of the fluid, rho is the density, and G is the acceleration due to gravity, and its value is 9.81 meter per second square, right? It is clear. So specific weight or weight density is this, right? So always remember, guys, always remember. Let's suppose for an example, let's suppose I'm saying what is the specific weight for the water? What is the specific weight for the water? What is the specific weight? So let's suppose I'm taking G as approximately 10 meter per second square. This is the approximate value of the G. It is clear? It is clear to you or not, right? So what is it? It is my, or you can say, okay, let's take its real value. Let's take its real value, because if you'll use every time this, then it's not good. 9.81. So what is the specific weight? Density is my 1000 multiplied by 9.81. What is it? It is my 9810. Yes or no? 9810 Newton per meter cube is my specific weight. It is clear? It is clear or not, right? So through the value of the specific weight, you can calculate the density of any substance. Density of any substance. Is it clear? Means let's suppose I'm saying that specific weight for a substance is my let's suppose let's suppose 480. What is the density of that substance? Just divide by the G. You will get the density of that substance. ठीक है, तो ये छोटी छोटी चीज ऐसे आपको याद करनी पड़ेंगी, और ये ऐसे सवाल पूछे भी जाते हैं, ठीक है। डायरेक्टली आपको डेंसिटी ना देके क्वेश्चन विल गिव यू द डेटा ऑफ योर स्पेसिफिक वेट. सो दिस इज हाउ यू कैन कैलकुलेट द डेंसिटी ऑफ दैट पर्टिकुलर सब्सटेंस. इट इज क्लियर? It is clear? And it is also called the weight density, right? Done? Okay, third is my specific volume. Please put the heading specific volume. Please put the heading specific volume. Okay. So specific volume is nothing. It is the volume occupied by the unit mass of a fluid, right? So it is my volume of the fluid, and it is divided by the mass of the fluid. It is my mass of the fluid, right? It is my V by M. So it is the reciprocal of the density. So specific volume is my 1 upon rho. So specific volume is nothing but it is the reciprocal of the density. Yes or no? It is the reciprocal of the density. So guys, it may be possible that they will give you the specific volume data, right? And we have to use the density data, then just reciprocal of that. That's it, right? So you can calculate density as 1 upon specific volume. Okay, so your specific volume, what is the unit of it? It is the meter cube. Volume unit is meter cube divided by mass is my kg. So meter cube per kg. Volume, meter cube, mass, kg, density, rho is the density. It is my specific volume. It is my specific volume. Okay. So I hope that these small things are clear to you. Yes or no? Okay. Let's again. Please put the heading 4th, specific gravity. Please put the heading specific gravity. And this is the important one. This is the important one, right? So specific gravity is basically the ratio of density of a fluid divided by density of the water. Divided by density of the water. Is it clear to you or not? It is clear to you or not? So specific gravity is the basically ratio of densities. Which density is your fluid density and divided by water. So this water density is fixed and this water density is basically at the 4.4 degrees Celsius. It is clear. And this is any fluid. So if I talk about what is the specific gravity, what is the specific gravity for the mercury? If I'll ask to you that the specific gravity of the mercury. So specific gravity means density of the mercury divided by density of the water. So it is my specific gravity of the mercury, right? So what is the density of the mercury? It is my 13600 divided by density of the water is 1000. So it is what? It is my 13.6. The specific gravity of the mercury is my 13.6, guys. What should be the unit? It is my unitless. Why? It is density. It is density, and it got cancel out both the units, and you'll have the 13.6 answer. Yes or no? Is it clear? Is it clear? Also in the specific gravity, guys, if you will multiply, it's the density of the fluid. If you will multiply the G in the denominator, and also you will divide the G in the if you will multiply and divide with the G, then this rho G will be your gamma for the fluid, and rho G for the, it is for the water. So specific gravity is the ratio of the gamma also. It is the ratio of the specific, or you can say weight density also. It is the ratio of the weight density also. It is clear? It is clear or not? It is clear or not, right? Okay, just try to understand one thing also here. See, what is this? If we'll say one term we can use also, it is a relative density. What is the meaning of relative density? What is the meaning of relative density? Guys, relative density means that you are comparing densities of two fluids. You are comparing the density of two fluids. Relative density. So relative density is nothing but it is the density of the substance 1 divided by density of the substance 2. Density of the substance 1 divided by density of the substance 2. It is clear? So this is my relative density. In the specific gravity, just try to understand it. In the specific gravity, the substance 2 is fixed, that is water. That is water, right? It is clear. So relative density you can calculate with any two fluids. With any two fluids. It is clear or not? You can calculate for any two fluids. Specific gravity is also relative density, but in the specific gravity, we basically compare the density of a fluid 1 with respect to the water. With respect to the water. It is my specific gravity. It is clear? Else, except the water, if you want to compare the densities, then that word that used is relative density. That word is used as relative density. It is clear to you or not? Tell me guys, it is clear to you or not? Yes or no? Done? Okay, right? Okay, so this is the basic class. This is the intro class for today's lecture, guys. I hope that these small things are clear to you, right? And these you can say the fundamentals of fluid mechanics, why it is important for us, and how we'll proceed it. All these things are clear to you guys. So फ्लूइड मैकेनिक्स को लेके घबराने वाली कोई बात नहीं है. डोंट वरी अबाउट दैट. आई एम हियर गाइस. इतने बेहतरीन तरीके से हम फ्लूइड मैकेनिक्स को करेंगे कि आपका ये वन ऑफ द फेवरेट सब्जेक्ट होने वाला है. डोंट वरी अबाउट दैट, राइट? अगर आप में से कोई प्रोसेस इंजीनियरिंग में भी जाएगा तब भी फ्लूइड मैकेनिक्स का जो कॉन्सेप्ट है वो आपको बहुत काम आने वाला है, बिकॉज इट इज अ वेरी इंपॉर्टेंट सब्जेक्ट. इफ विल टॉक अबाउट द it's a gate weightage, guys, then you can say from 8 to 10 marks is the weightage of this subject, right? 8 to 10 marks every time. 8 to 10 marks के क्वेश्चन हमेशा पूछे ही जाते हैं, right? So चलिए, so that's it from my side for the today's class, guys. I hope that you guys are, you can say, feel confident that yes, we can do the fluid mechanics. चलिए मिलते हैं फिर. Thank you so much. Yes, जिन्होंने अब तक एनरोल नहीं किया फटाफट से आप एनरोल करें और इस प्रिपरेशन में आए, और फिर ठीक है हम क्रैक करते हैं फिर गेट को एक अच्छी रैंक के साथ. बाय बाय, टेक केयर.